Last week, we started working on equalities, correct? Mm-hmm. Okay, so you remember, who can tell me, let's just review right quick, who can tell me the 4 different type of symbols of inequality? We have what? We have what? Greater than, less than, greater than or equal to, and less than and equal to, right? If I have an open circle on my graphing, where am I going to use it on? Am I going to use it on my greater than and less than, or greater than and equal to, or less than and equal to? On which one? Which one? Less than or greater to, right? And then my closed circle, it's going to be the greater than or equal to, or less than and equal to. Now, one more thing. Is the open circle, when it's an open circle, is the set closed or open? Is the number closed or open? So if I have, let's say, 2 is less than 2, is that going to work? So it's going to be what? It's not a solution. Okay? The number itself is not a solution. So what if I have 2 less than or equal to 2? Okay, that means it is the number itself is going to be a solution. Okay. Are we have any questions on that? So our test is going to be on writing inequalities, adding and subtracting inequalities, graphing them, and multiplying and dividing. Okay, let's go to the second slide. Let's go to the second slide. The second slide, we have multiplication and division properties of inequality, where C is going to be greater than what? C is going to be greater than 0. Okay, what does that mean? The only difference in inequality with multiplying and dividing, we have a special rule. Okay, we have a special rule that when we're dividing and multiplying, sometimes we have to change our what? Our signs. Okay, so let's look at this example. We have -6 is what? Less than 8. What do? Multiplying or dividing each side of an equality by the same positive number produces an equivalent fraction. So just give me, is -6 less than 8? So if I was to multiply it with a positive number, just give me any number. We're going to use this as an example. 4. So if I multiply 4 to both sides, what's -6 times 4? And what is 8 times 4? Is -24 still less than 32? So my rule, it still applies, okay? So that's going to be vice versa, even if I have greater than, less than or equal to, or greater than or equal to. These parts, they're going to be true for all 4 of the different equations. Yes? We just set a number. Yeah, we could just set a number, yeah. The only thing is that we're using a positive number. So give me any number. All we're trying to prove here is in the multiplication division property of equality, where C is going to be greater than 0, means that anything that we multiply on both sides with a positive number, the statement is still going to be true. Okay? So let's say we have 3 is greater than 2, right? Give me any number. Any number.
1.
No, let's use 1 bigger than 1, because we already know that it's going to still be what? The number itself, right? The property. So what number? Let's do 9. 3 times 9. It's going to be 27, and 2 times 8 is? Is 27 still greater than 18? My statement still stays true, okay? That's all we're trying to prove here, that their statement is still true. Let's go to the example number 1, multiplying by positives and then solve each equality and graph. What is the first thing I'm doing here? This is, by the way, we're no longer doing one-step equality. We're going to do a multi-step. Remember, first we're going to do what? Isolate, right? Who we're solving for here? Who are we solving for? X, right? So who am I going to get rid of? The 8. And I'm going the negative 8. And what's the inverse? To get rid of it? Positive 8. So I'm going to add 8 on what? On both sides. And X is greater than? What's negative 5 plus 8? 3. If I was to graph it, it's going to give me negative 3 and 3. Is it closed or open circle? It's going to be what? Open. And am I going to the right or to the left? To the what? Right. To the right. Remember, when the variable is on your left-hand side, just pay attention to whichever way the inequality is going. If your variable is on the right-hand side, do the opposite of what the inequality is going. Yes, Miller?
How do we know to subtract 8? Is it because the variable's on that side?
Yeah, because the variable's on.
Whatever side the variable's on, we subtract that side?
Sometimes you could multiply, sometimes we could divide, or sometimes we could add. And this, or subtract. In this case, because my 8 in front of it has a minus sign, that means it's a negative 8, okay?
Basically, we have to cut the 8 out and leave the variable alone?
Yeah, but remember, what you do to one side, we have to do it to the that side. All right, let's look at B. B is actually what we're having is negative 24 is greater than or equal to 3x. That 3x, does it mean that it's multiplication or division? Multiplication. And what's the inverse of multiplication? So what are we going to divide by? 3. By what? 3. So we could leave what? X on its own, right? And what's negative 24 divided by 3? 8. Negative 8. So negative 8 is greater than or equal to x. And if I am going to graph it, I have 8 and negative 8. Is it going to be open or closed circle? Closed. Am I going to the right or to the left? Right. To the what? To the right. Where's my variable? It's on the right-hand side. Always remember, if your variable, again, is on your left-hand side, you go where? Wherever the inequality is telling you to go, okay? If your variable is on the right-hand side, in this case, is your variable here on the right-hand side, you go the opposite of what the inequality is telling you. All right, so that one, this is when we're doing with what? Positive. We're basically dividing or multiplying with what? Positive numbers. But now becomes the next one. When we're multiplying and dividing propers of inequality where C is less than 0. That means that when multiplying or dividing each side of equality by the same negative number, the direction of the equality symbol must be reversed to produce an equivalent equality. Okay, so let's look here. We have negative what? Negative 6 is less than 8. Who can give me any negative number that we could multiply? Any negative number. Negative what? Okay, negative 2. Let's multiply. Negative 2. We're multiplying with negative 2. What's negative 2 times negative 2? I mean, negative 6 times negative 2. I was going to say negative. What is it? Positive 12, right? And what is 8 times negative 2? Negative 16. Now, my inequality said less than. Do I have to inverse it? So now it becomes what? And it kind of makes sense, right? kind of makes sense. If I leave it where it's less than, that means that it's 12 less than negative 16. So why are we inversing it? Because when you're multiplying or dividing by a negative number on both sides, what do? We reverse our inequality sign. So let's look at the division example. We're going to use the same thing. We're going to have, let's say, 4. Now let's do 16 is greater than, let's say, give me a second. I'm going to have what? 16, let's use 16. Let's use 16 is greater than 18. Oh no, I'm sorry, 16 is not greater than 18, right? Let's use 12. Is 16 greater than 12? That's a statement, right? Now, let's divide by a negative number. Let's divide by a negative number on both sides. Give me 1. Give me a number that we can divide. A negative number that we could divide on both sides. Yes.
-4.
If we use -4 on both sides, what is 16 divided by -4?
4.
-4. And what is 12 divided by -4? -3. If I leave my greater than sign, does that make it true -4 is greater than -3? No. Which is bigger, -4 or -3? -3. So therefore, do you see why you have to change the reverse? You have to reverse it. So when we're multiplying or dividing by a negative number on both sides, what do? Do the inverse. Let's practice on the next. Let's do some practicing. Here is telling me 2 is less than y minus -3. What's the first thing I have there? I have a what? I have a minus and a negative there. What does that become? That becomes a positive. So I have 2 is less than y plus 3, right? What do I do now? Subtract 3 from both sides. So what's 2 minus 3? -1. Is less than y. Do I have to change it here? The only reason I'm giving you this is that you could see the difference, okay? I don't want you guys, just because this is where I have students confusing themselves. This is a what? An equality of subtraction. The number A is an equality of subtraction. We did that last week. I just showing it to you so that you could see that there's a difference when there is an equality of subtraction, and equality addition. The A is an equality of subtraction. But B is going to be different, okay? B is going to be different. So if I was to graph it, is it going to be open or closed circle? Open. And is it going to go to the right or to the left? To the what? To the right. This is where you guys, and I keep hearing it. Remember, write it down somewhere so it could just stick, okay? You could easily get confused. If your variable is on your right, you're going opposite to where the inequality is showing you. If your variable is on the left, you go where the inequality is showing. All right, B, we have -7y is less than or equal to -35. What am I going to do here? I need to solve, I'm going to do what? Divide by what? Am I dividing by a negative? Yes, right? So that means y is now what? Is y now, what is going to be y now? Greater than or equal to what? To what? Is it +5? Yes, because a negative and a positive is what? A negative and a positive becomes? I'm sorry. A negative and a negative divided by negative becomes what? I'm just trying to move this here so you guys, I do not know why. It doesn't, keeps moving around. All right, let's graph it. Is it gonna be open or closed? It's gonna be what? Am I going to my right or to my left? To my what? To my right, because my variable is where? On my right hand side. Okay, so I'm able to go wherever my inequality is telling me to go. All right, can I go on to the next slide? Did we write this down? Harmony? You got it? Almost? No worries. Okay. All right. Number 1. Let's practice. What is the first thing I'm doing here? I'm going to add 7 to what? I'm going to add 7 to both sides. So I'm left with n is greater than or equal to 6. There you go. Do I need to do any division or multiplying here? No. That is the inequality of what? Subtraction. Number 2. What do we have there? We have negative 6.4 is greater than or equal to 1 minus what? 5w. Who am I solving for here? My w. So I need to start getting rid of it, no? What am I going to get rid of here first? By what? Can I get rid of my 5 yet? My term of 5? On this part of the equation, who should I get rid of first of? The 1. And is that 1 positive or negative? Positive. So what's the inverse? Negative what? 1 on both sides. So what's negative 6.4 minus 1? Negative, yes, negative 7.4 is greater than or equal to negative what? 5w. Now what am I going to do? Do I divide? What am I going to divide by? Negative 5. Did I divide by a negative? So that means I have to do what? Reverse my sign. So I'm left with what? 7.4 over 5 is what? Less than or equal to w. So my equation became completely positive, did it not? Because I'm dividing by what? Negative. Do we see why negative 7.4 over 5 became positive? They're both negative. So that means that this cancels out. Did we copy this? Miller, did you copy it?
Yes, ma'am.
Okay. Let's go on number 3. What do we have in number 3? Uh-huh. 4b is greater than or equal to 36. What do I do here? By what? So I'm left with b is greater than or equal to 9. Do I have to reverse my inequality? Because I divided by what? A positive number. Number 6, we have a minus sign with a negative sign there. What do we do there? We do subtract by 5 by both sides, but we always do what? Remember that this becomes a this becomes a positive. So we have x plus 5 is less than or equal to negative 5. Now what do? Now we do subtract negative 5 to both sides. So x is less than or equal to, what's negative 5 minus 5? Negative what? 10. Negative 10. Do I have to reverse my signs? I'm just subtracting, okay? When we subtract or add an equality, properties of an equality, we do not do what? We do not change our signs. Only when we're dividing and multiplying by a negative number. All right, number 7. Again, we have negative 1 is greater than or equal to negative 1 minus 10z. What is the first thing I need to get rid of here on this equation, or inequality? Negative 1. And what's the inverse of it? So I'm going to have plus 1 on both sides. I am left with what? 2 is greater than or equal to negative 10z. What do I divide by now here? 10. By what? Are we dividing by a negative? Do I have to switch my... I have to reverse. So it's going to become what? Negative 2/10 is less than or equal to z. And let's do one more. Number 8. In number 8, what am I dividing by? By what? I'm going to divide by negative 9. Negative 9 divided by negative 9 becomes what? Positive m, right? Do I reverse my inequality signs? Yes. So it's going to be m is what? Less than? Less than what? -7. -7. And that's your answer.